Hello everyone, so this is problem number 38 from the chapter Center of Mass from Verma. Here is saying that two friends A and B, each weighing 40 kg, are sitting on a frictionless platform some distance d apart. A rolls a ball of mass 4 kg on the platform towards B. Okay, so let me take A as a block like that and B as a block like that. So there are two friends, they are sitting on a frictionless floor and A having a ball of mass m. So this is 40 kg, this is 4 kg, and this is 40 kg. Okay, so A is, and this distance is d meter apart. That's fine. So he's saying that the ball has a fixed speed 5 meter per second on the platform. Okay, so ball is moving at a fixed speed, that is 5 meter per second on the platform. So what is happening here? A is throwing the ball to the B, then B is catching and throwing ball to the A with the same speed with respect to ground. So what are the questions? Part A is asking, find the speed of the A after he rolls the ball for the first time. Okay, so after he rolls the ball, so this is A 40 kg. Let he is moving speed V, ball is 5 meter per second and B is still at rest. So initially system was having zero momentum, but and now there is having some individual momentum, but the momentum of the entire system is going to be zero. Why? Because there is no external force which has applied on the system. So the net external force on the system is zero. Then definitely we can apply the conservation of linear momentum. And initially it was zero, and finally also it should be zero. That is this 4 into 5 minus 40 into V. So that V will be 0.5 meter per second. So this is the speed with which A will bounce back. Now let us go to part B. Saying, find the speed of A after he catches the ball for the first time. Okay, so what is going to happen here? Let me write here that now A is going to move with the speed of 0.5 meter per second, and then B has thrown the ball to A. So this 4 kg now moving with the speed of 5 meter per second, and now this A will catch the ball, then it will have a mass of 44 kg, and suppose they are going to move with the speed V1. Why I am writing V1? Because it is the first catch. So here also we'll apply the conservation of linear momentum, that is 40 into 0.5 plus 5 into 4 is equal to 44 into V1. So V1 you will get as 10 by 11 meter per second. So this is the speed of A at first catch. Now let us go to part C. Find the speed of A and B after the ball has made 5 round trip. Okay, so in the first catch it is V1. Now let us look at what is going to be second catch. So this is A moving the speed of B1, that is 10 by 11. Now he is going to, now this is 44. Now he is going to throw the ball 5 kg with the speed of 4 kg with the speed of 5 meter per second to the B, and let that speed be B2 dash. Then what will be this B2 dash? And after this again this 40 kg and this 4 kg again it will come to him. This is the second catch, and this is going to move with the speed V2 dash, and this 44 kg now they will move with V2. So this is after second catch, and these all are intermediate things. So here we'll apply conservation of linear momentum, that is 44 into 10 by 11 is equal to 40 into V2 dash minus 20. This is 5 into 4. So V2 dash will get as 15 by 10 meter per second. Now look at this situation here. Now there's 40 kg and 5 kg. So 15 by 10 into 40 plus 5 into 4 is equal to 44 into V2. So this is the situation here, and if we calculate V2 then you will get 10 by 11 meter per second. So if we can look at the situation, so there is a trend, At first catch, it has speed v1, that is 10 by 11 meter per second. At the second catch, it has a speed 20 by 11 meter per second. So similarly, at each catch, it is going to increase the speed by 5 by 11 meter per second, each catch and each throw. So he had this ball, now he has thrown, then it has increased to 15 by 10. Now he has again caught the ball, and again it has increased to 5 by 10 more. So this is at first catch. So for nth catch, we can generalize it. For nth catch, it has a speed of 10n by 11 meter per second. So for fifth catch, it has the speed of 50 by 11 meter per second. Now what is the velocity of B at this situation? So A, having a mass of itself and the ball, that is 44 kg, moving the speed of 50 by 11 meter per second. So this is 40. What can be the speed of B? So let it be V. So we can say that initially there was zero momentum, so finally also it should be zero momentum. Then we can say that 50 by 11 into 44 is equal to 40 into VB. So VB is equal to 5 meter per second at this situation. Now let us go to part D. What is saying? D is asking how many times A can roll the ball. Okay, how many times A can roll the ball? So we know that ball is having a speed of 5 meter per second. If the speed of B, this VB, if it has crossed 5 meter per second, then the ball thrown by A will never reach to B, and again it will not come to A. Then we can say that let the nth catch, the speed of VA is 10n by 11 meter per second at the nth catch, and the velocity of B is, suppose VB, which is greater than 5. So what is VB? So this is 44 and it has a speed of 10n by 11. This is A plus ball, and now this is B, which has a speed of VB, which is greater than 5. So we'll apply conservation of linear momentum here, that is 10n by 11 into 44 is equal to 40 into VB. So VB is equal to okay, so VB is equal to this 4 and this 11. VB is equal to n. VB is equal to n. Now VB should be greater than or equal to 5. Then it will never, the B ball will never reach to B. So that n should be greater than or equal to 5, or VB should be greater than 5. Then if n is greater than 5, means at sixth catch, 6 times that A can catch the ball. After the sixth catch, the ball is never going to come back. Now what is E part? Where is the center of the mass of the system A plus B plus ball at the nth trip? Okay, so at the nth trip. So whatever situation may be, the net external force on the system is going to be 0. It means the position of center of mass is going to be constant from the beginning. So at initially A was at here and B was at here, and A was having a ball also, so the center of mass was somewhere here. So let this be the x coordinate of center of mass. So this is x is equal to 0, this is x is equal to d. So we can say that x coordinate of center of mass is equal to mass of B, that is 40 kg, into coordinate d upon 40 plus 40 plus 4. So it is going to be 10d by 21 from A towards B. So this is the location of center of mass after nth trip. Means after nth trip the ball will come to A only. So this is the situation I am taking at initial, because the center of mass is not going to shift.